gone tomorrow, so this will give you something to ride on the bus. I'm also trying to see if I can record and use this new software so you get double wins here. All right, enjoy your trip, but let's go ahead and get to this. So at the beginning, they got some silliness here. They're saying, hey, look at this. We use abbreviations like Mr. We don't pronounce this Mur Jones or Ms. Smith, or I don't know how you pronounce that. We use abbreviations for words all the time. And in math, we have these three trigonometric functions, they're called. And we got sine, cosine, and tangent. But here's their abbreviations, and so we don't pronounce this sin. We still pronounce it sine, just like we pronounce this Mr. and not Mur. Okay, so this is the sine of angle theta, or just sine theta, cosine theta, or cos theta, and tan theta, or tangent theta. Okay, so that's how we pronounce those things, sine, cosine, and tangent. And just as a review here, whenever you're using the trig function, they define very specifically that if we are talking about the function called sine, what is the sine of an angle? Well, it is the opposite over hypotenuse. So let's fill that in. We'll go opposite. What's it mean by opposite? Opposite, I guess I should be really specific here. Opposite side of angle theta. It's going to be hard to cram all that in, but that's what it is. I'm just going to write opposite for the sake of time. Over hypotenuse. We'll just use height for that. So this is the word that lots of times in math classes they say, hey, remember these so. So that's a so. And then ka here, that's adjacent to the angle and the hypotenuse. So adjacent over hypotenuse. Some students have a hard time remembering where the hypotenuse goes in these things. It's in the denominator for sine and cosine. Okay? And then tangent's the weird one. It doesn't have hypotenuse. It's just the opposite over the adjacent side. So if here's my angle, opposite, the eyeball sees across to the opposite side. Okay? Then it has two sides adjacent, but one is called the hypotenuse, and so the other one is the one that is the adjacent. You could even call these the opposite leg and adjacent leg, because this is the hypotenuse. And opposite and adjacent are always legs, not that. All right, and then, okay, so tangent, TOA, opposite over adjacent. So there's our trig functions. All right, and we've talked a little bit in class how to use them. If you need some help with that, ask me and I can help you a little bit. We don't really need to use those so much right now, as we just have to know those ratios, opposite, adjacent over hypotenuse, and opposite over adjacent. Okay, and so now we're going to look at our unit circle here. So given an angle in standard position and a circle centered at the origin, there's a point P where the terminal ray intersects the circle. So here's our terminal ray, and we got an angle in standard position, and there's this point where it intersects the circle. Okay, so this arc has been subtended by this angle right here. Using SOHCAHTOA, we can find the value of the sine, cosine, and tangent of this angle right here. So let's see if we can find the sine of this angle. Now notice I don't even have a triangle in here. Okay, so I'm going to build a triangle, and I'm just going to drop a perpendicular line to the x-axis straight down. So this is now a right angle there. And this point's coordinate, you can see, is this side. That would be the x value of that coordinate, and this would be the y value of that coordinate. And so if I wanted to use my trig functions on this angle right here, let's go ahead and do the sine function. So we'll go sine of theta. Sine of theta. I'm going to write it right here. Sine of theta would be equal to what? Let's take a look here. So here's the angle. This is my hypotenuse. I can label him right there, hypotenuse, if you want to. Generally, we don't name opposite or don't name our opposite and adjacent side. We just kind of use them, because if I was talking about this angle up here, which I'm not, but it does switch opposite. Now opposite would be this side. So generally, my opposite side, now I just look and I go, well, that'd be y over my hypotenuse. Opposite over hypotenuse would be y over hypotenuse. So let's see what it says down here. I've just defined sine of the angle. The sine of the angle in the ratio of it, the sine of the angle is the ratio of the vertical displacement of P from the x-axis. Let's see here. Vertical displacement of P. So there's P. There's the vertical displacement. So that's just your y value. Notice the phrasing, the vertical displacement of P from the x-axis. That's just your y value. So this becomes y over to the distance between the origin and the point. So they're talking about the distance between the origin and the point way out there. Well, that's just the radius. This distance from origin to point, so this is just r. So your sine is equal to y over r. This is not a unit circle, by the way. We'll do that in a second. So we don't know what this radius is, which is kind of nice, because now sine of the angle, the ratio, or theta, is sine of that angle is defined if I know the y value over the radius. Cosine of an angle, so again, I'm just looking at my triangle that I built up here. If I want the cosine's adjacent, so adjacent to the angle, there's two sides. I want the adjacent leg, so I want x over hypotenuse, adjacent over hypotenuse right there. So I'll do x over hypotenuse for my cosine. Okay, let's go ahead and write that thing out as, I shouldn't say hypotenuse, because my hypotenuse is r. Sorry about that. So it's now adjacent over hypotenuse, or adjacent over r. So that's pretty easy. You can see the language they're using, the horizontal displacement of P from the y-axis. So if this is my point P up here, its distance from the y-axis would be measured here. But I could also measure it down there. That would be the same length. And so that is my x value over the distance, over the distance between the origin and point P. Origin and point P, again, is your radius. And finally, our tangent of theta. Tangent is opposite over adjacent. So this would be y over x right here. So tangent theta equals y over x. Notice no radius at all in that. They got a little equal sign here, and I want to explain this equal sign to you. If I take this function right here, so cosine of theta is equal to x over r, I could take both sides times r, and I find out x is equal to r cosine theta. So this would be r, x is r cosine theta. This would be r cosine theta. And I can do the same thing with my sine function up there. I could go take it times r, and I'd get y equals r times sine theta. So r sine theta, and we get this little weird expression. This is called an identity. And it's called an identity because now we've just defined tangent as being equal to two other trig functions, or the ratio of our sine to cosine. This is a little formula you want to remember. Tan theta equals sine over. Here is side number 2. So let's write down a few things we know from our first page. Sine of an angle is equal to the y value over the radius. Cosine of an angle is equal to the x value over the radius. And the tangent of an angle, when we're talking about a circular functions, is your y over your x. Okay. Something you really want to start associating together are the fact that sine is y, cosine is x. Sine y, cosine x, tangent y over x, or sine over cosine, that identity from page 1. So let's see here. Here is my angle. There's my initial side, sorry. There's my initial ray or initial side. Then I measure my angle this way, and I get to this point P. And they're asking, hey, what's the sine of this angle here? So what's the y over the r value? Okay, y over r is the sine value as we define it in mathematics. Okay? So let's see, the y and x are easy to find. I'm just going to label these things so you remember they always are in x, y form. The part I don't know is I don't know what r is. I don't know this distance right here. They haven't told me any, they haven't labeled this tick mark here. So I'm going to have to try and calculate the radius of this. Thank goodness they've shown me a radius over here, because over here I could actually draw a triangle to figure out the radius. Just go from your point and go, either straight up or straight down to get to the x-axis. Okay. So you could see this, like if I was doing this on this triangle down here, here's my point P. And so if I wanted to make a right triangle, I'd drop my right perpendicular line to the x-axis right there. Okay, and that would be my triangle. And now that I've got the triangle made here, this is what it helps me do. I go, well, I don't know R, so let's label him R. Notice these are both R, okay, because this is center to edge of circle, center to edge of circle. So those are the same R values. But when I draw this triangle, and I know this point, I've got enough information to actually know how long this side is. The Y value is 1, so this is 1 unit tall. And the X tells me how long this section is right there. This little side of my triangle is exactly over there at -3. And so now I can use the Pythagorean theorem to find my radius. I can go leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared, or it really takes on the form x squared plus y squared equals r squared, your radius squared. So let's put in our x value, -3 squared, plus our y value, which is 1 squared. That would equal your radius squared. Now we just solve this for r. So that's 9 plus 1 equals r squared. So r squared is equal to 10. So r is equal to the square root of 10. Now it is plus or minus technically here, but we always in these things are talking about our radius as a distance here, and distances are always positive. How long is the radius? The radius is root 10 long. Keep in mind that is just a number. That's about 3 point something. So let's now go ahead and answer these. So these are real simple. I know my y value and I know my radius, so it's 1 over root 10. I know my x value is -3 over root 10. And y over x would be 1 over -3, like that. And so I know the tangent of angle is -1/3. Generally, you put that negative sign in the numerator like this, -1/3, or like this, -1/3. All those are acceptable. The 3 over root 10 here, -3 over root 10, and this 1 over root 10, those are acceptable but not exactly perfect. We don't like the radicals in our denominators, so we'll do our little quick fix here. We just take it times the version of 1, root 10 over root 10, which gives us 1 root 10, or just root 10, over root 10 times root 10 is the square root of 100, which is just 10. So now it's root 10 over 10. Do the same thing. See, down here, I got to take it times a root 10 over root 10, and I get -3 root 10 over 10. So there's the cosine, there's what the sine is equal to, and then finally our tangent is just done. We don't have to do anything about simplifying it. All right, there's problem 1. If you'd like to try problem 4, 5, and 6, or example 1 through 3, if you'd like to try the next one, just hit pause and try them on your own. Now, number 4, I'll just go ahead and do it. Hopefully you've paused it and had time to try and do this yourself. So sine of alpha they're using, so that kind of looks like a fish there. Sine of alpha equals y over r. Cosine of alpha equals x over r. And tangent of alpha. And what I encourage you to do is just keep writing these things down so you get them memorized. So let's see here. I have, let's see, my angle I'm talking about, alpha, is this big angle all the way around this thing. So there's the angle we're talking about. Here's its terminal side. There's its point P. There's his x. There's his y value. I just need to know the radius here. And again, I can label both of these as r. Okay, so what's the radius here? Well, I noticed this time they've given me the point out here is at 6, 0. So I know exactly how long r is. R must be 6 units long, which is why it has coordinates at that point of 6, 0. So I already know the radius in this. Okay? So I can just start answering it. So let's see, my y value is negative 5.4 divided by my radius of 6. So we certainly are going to use our calculators to figure this out, because you don't want to leave a decimal in a fraction like that. And it's kind of mixing your forms. X is 6 over my, x is not 6, x is 2.6 over my radius, which is 6. My y value, negative 5.4, and my x value, 2.6. So all these we're going to get out a calculator, and we'll attack them that way. So I'm going to add my calculator to this page if I can. Add calculator, there we go. Just got a nice simple one here. So negative 5.4, that's supposed to be negative, so there we go, divided by 6. So this is sine of theta, negative 0.9. Now this is kind of unwieldy the way I've written all that, so it looked like this, sine of not theta but alpha equals negative 0.9. All right. By the way, we can start to kind of figure these things out. I don't want to sidetrack too much, but I know this angle has to give me a negative y value now, and so that kind of helps me think about quadrants and where this angle terminates at. If my y value, my sine, comes out to be negative in this case, at least I know I'm down in one of these quadrants, because this is where the y values are negative. Okay, so this sine starts to matter to us a little bit. Let's do our next division here. So I've got to do 2.6 and divide it by 6. So this is about, let's write it this way. Cosine of alpha, therefore, is equal to about 0.43. And then finally the tangent of alpha, so I'll take my negative 0.54. Now I just usually go 5.4 divided by 2.6. I know the answer is negative. So tangent of alpha is equal to 2.08, we'll call it. That's pretty simple. Let's see here now. When using the unit circle r is 1, the trig values can be simplified. So if we think about these for a second, if we're using r is 1, so this is sine of alpha, or theta, sorry, equals y over r, but y over 1, so this just is y. So in the unit circle, your sine is just your y value. Similarly, the cosine being x over r, if your r is 1, because it's the unit circle, then it's just your x value, and finally tangent is just your y over x. Okay, no r in that at all, so it doesn't affect the tangent function being a unit circle or not being a unit circle. So man, now we got some really simple formulas, okay, for what cosine and sine are, but that's only, again, if you're on the unit circle. Okay, so now our unit circle even gets more powerful for us. So each figure below is given in the xy plane with the center at the origin again, angle of theta in standard position, find the value of each expression, and here's what I want to point out. See this point here? It's at 1, 0. Its x value is 1, which means it has a radius of 1, which means this is a unit circle. And if it's a unit circle, when they ask for sine of alpha, all I need is to know what the y value is for that end terminal side for point P. So let's look at our diagram here. Here's my initial side, and they've measured their angle alpha all the way around to there, and there's my x and y values. That's actually my sine and my cosine values, essentially. I don't have to do, 0.76, this negative 0.76 over r, because my r is just 1, so it just jumps to the y value. So the sine of alpha is the y value here. Negative 0.76. The cosine is just the x value, negative 0.65. And the tangent of alpha is the y value over the x value. And see, we get a positive tangent value. And again, we'll just grab our calculator. And I'll just ask it, what is 0.76 divided by 0.65, 1 point something? It's about 1.17, and it's going to be positive. All right, on to the next page here. Oh, that's your practice problems. So good luck.